Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the topic work power energy assignment number 19. Now in this assignment let us see your first question, which is given as a body of mass 2 kg moving up has potential energy 400 joules. Has a potential energy as 400 joules. Now potential energy is given as 400 joules and kinetic energy is given as 580 joules at a point P in its path. The maximum height reached by the body is. He wants the maximum height. Now let us think the maximum height. See, I am going to draw the situation over here. This is the ground level. From ground they have thrown some particle until a particle is considered as point P. At point P the total energy is like somewhat PE plus KE. Now what is your potential energy at this place is 400 joules. 400 plus what is your KE over here? What is your KE? KE is given as 580 joules. So 580 joules. It is going to be somewhat around 980 joules. So the total energy over here is going to be 980 joules. Now he wants the total maximum height at a particular point, 980 joules. To completely, if it moves, up to what height will it reach is the question. Up to what height it is going to reach is your question. Completely, if you want it for complete height, we will use some other color. For complete height, what will be your height he is asking. Let us think it as capital H. Now when you want to talk about capital H over here, let us think the energy when it is reaching to a certain height, kinetic energy is going to be 0 because velocity is going to be 0. At that particular situation the potential energy over there is going to be PE is equals to mg capital H, right? At total height, your height is going to be capital H. Now let us think the total energy over there while reaching that complete path is nothing but mg capital H is equals to, this energy is also going to be there, which is PE plus KE, which is 980 joules. So from here M is given as 2 kg, G is given as 10, H is given as height of the body. You have to find out maximum height at maximum height. Okay, the maximum height reached by the body is now next 980 joules. So from here capital H is going to be equal to 980 by 20. 0 0 gets cancelled. 2 ones are 2 4s are 9s are. So height should be measured in meters. So your height is 49 meters. It is first option, right? Hope this is helpful. Let us go for next question. Now in this question you have a body is moving horizontally at a height of 10 meters, has its potential energy equal to kinetic energy, then velocity of the body is. He is asking you velocity and he has given you height. So when you say energy, potential energy is equal to kinetic energy over here, he is telling PE is equal to kinetic energy. So in this kind of a case you have to equate it, like you can say PE is equals to KE. That means from the formula point of view, mgh you will be having, mgh is equals to KE is half mv square, right? Now from here gets cancelled, and you have height as 10. G, you can, they didn't give you anything, so you have to take 9.8, and height is 10 is equals to half v square. Now from here, if you observe, you are going to get 98 into this 2. If you send it that side, you are going to get v square. 196. So you are going to get 196. V square is equals to 196. So V is equals to root 196. Now root 196 is 14 meter per second. So your velocity is 14 meter per second, which is option number 2. Hope this is helpful for you. Let us go for the next question. Now this is your second question, third question. In this question, they have given you a slab of mass m is released from a certain height. Okay, there is a slab of mass m, it is released from a certain height, which is capital H, on the top of a spring of force constant K. The maximum compression of the spring is Y. Then, okay, now let us try to draw this situation which has been given over here. Now there is a spring, actually there is a slab, okay, a slab of mass m, and this is a slab. Let us think this is a slab and its mass is m. It is released from certain height h. This is height h, we will take h, and you have a spring over here. Okay, you are having one spring over here. Let me draw a little better. You are having some spring over here. Now this spring, this slab from certain height, it went and fall on that spring. Now the maximum compression of the spring is taken as y, and a force constant of the spring is given as k. So the distance the spring has got compressed, let us take it as y. Spring got compressed for y. So the total distance this mass has traveled is this h plus y. Now let us take it as h plus y. Right? Now when you take the total distance as h plus y, your potential energy is going to be mg. Total distance is h plus y. Amount of energy is equals to work done. So the work done by this spring with a spring constant k is nothing but half k x square. Sorry, it is y square, because the distance which it got compressed is y square. So we'll take it as y square. So now let us see which option it is. It is option number 4. Hope this is helpful for you. Let us meet in the next assignment. Thank you.